Okay, so next up we're going to talk about how to graph square root and cube root functions. So we're going to start out with just a basic table of values. So y equals the square root of x, which is the same as y equals x to the 1/2. If you kind of convert that, power over root, there's a little invisible 1 and a little invisible 2. So x to the 1/2 and the square root of x are the same thing. So let's take a look first of all at our table of values, just a regular table of values. Okay, well, because this is a square root graph, I know I can't plug in any negative values for x, right? Because then we'd have imaginary stuff, and we're not dealing with the complex plane here. We're just dealing with a normal one. So I'm going to start with 0, right, 1, and I'm going to be kind of strategic about what x values I pick here. I want to pick values that I can actually take a root of. So I'm not going to use 2 or 3. I'm going to jump to 4 and then 9, right? Because I can take square roots of these numbers. Okay, so then from there, if I plot these points, here's 0, 0, there's 1, 1, here's 4, 2, and then 9, 3, it's an 8 by 8 grid, so 9, 3 will be just off the grid. So it looks like that. Okay, so you can kind of look at this and you can sort of see this kind of looks like if you took a parabola and you chopped it in half and then tipped it on its side, right? That's sort of the shape that we have going on here because the ratio between these points are the same, right? Because they're the same numbers, they're just backwards. Okay? All right, so that is a square root graph. Now let's take a look at a cube root graph. Cube roots, as we've discussed, you're allowed to have negatives inside of a cube root. Again, I'm going to be kind of strategic though. So I'm going to use -8, -1, 0, 1, and 8 for my points because those have perfect cube roots. Okay, and remember, -2 times -2 times -2 is -8, so that one works out. All right, and then when I graph this, it's an 8 by 8 grid, so let that help you figure out where 8, 2 is going to go. There's my graph. Okay, so this guy, you can sort of take a look at this and you can sort of see where this cube root function, how it's connected to an x cubed graph. Remember x cubed kind of came up like this. It was that weird squiggle thing. You can see the commonality in the shape. And if you sort of like envision how we come up with transformations, you can like fold this paper along the line y equals x, and you can see how that graph would translate over into this one. Okay, so those are our two basic functions. So from there, we then have a whole bunch of transformations. So it's our good friend, the transformation, just like we've always been doing since day one of this class, right? We're gonna have some number here, right, that does your vertical shift, right? And then equals, if you have a number on the outside here, right? This is a vertical shrink, stretch, or flip. Right? And then in this case, instead of having parentheses, we're actually going to have a root. There's going to be some index number up here, whatever it happens to be. That just tells you what your shape of your graph is going to look like. Okay, if there's a number in here, right, just as a reminder, how the setup is going to be, right? This guy right here would be a horizontal shrink, stretch, or flip. And this guy is going to be your horizontal shift. Okay, and don't forget that your horizontal stuff is backwards of what it looks like. So if this is a +3, it'll take you actually to the left 3. Okay, technically it's backwards of what it looks like over here. A lot of times we'll rewrite this with the vertical shifts over at the end. Or a lot of times what we'll do when we're looking at these graphs is sometimes we'll put the square root at the beginning, sometimes we'll put it at the end. So this guy over here, he might sometimes get transferred into this spot instead, in which case the signs would do what they look like they should. All right, so let's look at an example here. So this guy right here, we got this +2, which is not quite lining up here, but this is where we use our common sense, right? This is a vertical shift. It's this number that's been moved over here. So this guy right here is my vertical shift, right? And it's telling me that I'm moving up 2. Okay, so square root of x, but up 2. So here's my new starting point. And then from there, I'm just going to plot my table of values. I'm using my modified table of values. So that's 0, 0. Here's 1, 1. 4, here's 4, 2, and then 9, 3 would be over here. There's my graph. All right, this guy over here, so this one has a similar thing, right? This -5, even though it's at the front now, that is still a vertical shift. So this is still a vertical shift, right? It's taking me down 5. And I'm going to use my cube root graph. So I'm starting by shifting down 5, 3, 4, 5. So there's my starting point. That's my new 0, 0. So plotting the rest of this modified table of values from this new origin, right? -8, -2 would be over here. Here's -1, -1. Here's 1, 1. And then there's 8, 2. Remember I told you at the beginning of the year that we were going to learn transformations and we were going to use them over and over and over again throughout the year? You didn't believe me? Yeah, here they are, transformations. We're not done with them yet. All right, and then this guy down here. So this is going to have a horizontal shift in it, or I'm sorry, a horizontal flip in it. So here's what we're going to have to do with this guy. Dealing with the inside part here, anytime you have a number that's in front of your x, you need to start by factoring that out. So the first thing I'm going to do is I'm going to rewrite this as the square root of -1 times x minus 4. I factored out the -1. Okay, you would do the same thing if you had any kind of like numbers there, like if it was like 3x instead, you'd factor out a 3. Okay, and then what this is telling me is that now I'm going to have a horizontal flip because it's a negative. And now this guy, remember backwards of what you'd think, this is going to move me to the right 4. Okay, so you can't pull your left-right transformation off of the original graph or you'll get it wrong. You got to start by factoring out anything that's a coefficient or any kind of leading coefficient on this x value. Okay, so let's take a look at this graph. So I know it's a square root graph and I'm moving to the right 4. So 1, 2, 3, 4. Here's my new starting point. And we're doing a horizontal flip. So what I'm going to do with this is anytime that I would have moved in a positive direction, I'm going to move in a negative direction. So here's 0, 0. 1, 1, I would go over this way and then up 1. So I'm going to go this way and up 1. Okay, 4, 2, I would go 4, 2. Well, I'm going to go 4, 2. So that would be here. Okay, 9, 3, I'd go 9, 3. Well, now I'm going to go 9, 3. And there's my last point. So all I'm doing is instead of going to the right, I'm going to go to the left. And if for whatever reason we had points that we needed to go to the left, we would go to the right instead. Okay, and that is how you deal with a horizontal flip. Okay, so this is basic graphing of square root and cube root functions. As long as you remember all your transformations, this should not be a big deal. These are easy table of values to make, right? And then it's just the same transformations that we've been looking at since literally day 1 of this class.